The last thing we're going to talk about in organic chemistry here in grade 12 is the concept of an amide. Now, amide, by definition, is a C double bonded to an O, which is bonded directly to an N. It's this signature here that makes something an amide. Now, amides can be classified as primary, secondary, or tertiary. So in this particular case, if you've got it bonded to 2 hydrogens at the end, this makes it a primary amide. If it's bonded to 1 carbon, it's a secondary amide. And if both nitrogens are bonded to a nitrogen, or both carbons are bonded to a nitrogen, it's a tertiary amide. Now, when it comes time to naming amides, it's going to be a very similar process to what we did with carboxylic acids, combining with some of the ideas we learned with amines. Okay, so first, we're going to end it, instead of with an oic acid, we're going to end it with an amide. So that's where it's similar to carboxylic acid. It's similar to naming to an amine, because if we've got secondary and tertiary amides, we classify what's on those carbons through the N here, the N dash. So we've got this example right here. Well, we can see this is a primary and amine, so the ending we know is going to be an amide. Now, if we count the number of carbons, it's 1, 2, 3. It's a prop chain, so therefore it's going to be propanamide. If we look at this example right here, what we're going to see is that we've got 2 pieces here. We have 2 pieces off here that are methyl groups. So we know the beginning of this is going to be N-N-dimethyl. So now we can concentrate on the main chain. We've got 1, 2, 3, 4. We've got a methyl group on spot 3, and it's a bute chain. So therefore, it's going to be 3-methyl butanamide. Now, when we're drawing them, yet again, we need to take a look at what we've been given. So we know it's going to be a propanamide chain. So we've got C, double bonded O, N. Now, on one of these ends, we've got a phenyl group. If a phenyl group doesn't sound familiar, well, what we can do is we can take a look at here, our suffix group. Now, we can see an aromatic like a benzene is considered a benzene if it's the most important thing. But if you can see, amides are higher up on this list. So therefore, it's a side chain. So that's what a phenol looks like. So if we go back here, we're going to draw the benzene ring right here. We'll have a hydrogen right here. So remember, if it's the main chain, it's called a benzene. If it's a side chain, it's called a phenol. So we've done the side chain here. We've got propanamide, so C, C. We've fulfilled everything we want on there, so we can just add our hydrogens. Our next example here, N-N-dimethyl 4-chloral pentanamide. So that's going to be 1, 2, 3, 4, 5. So we've got double bonded O, because there's our pent chain. We've got 1, 2, 3, 4. We're going to have our chloral here. And the N-N-dimethyl implies that we are going to have CH3 groups right here. And that's what it's going to look like. Now, amides, simplest of them are considered liquid at room temperature. And as they have become secondary and tertiary, means they have lower melting points, because there's less opportunities for hydrogen bonding to occur. Remember, hydrogen bonding is going to occur at this NH group within the cloud of an oxygen from the C double bonded O. That's the spot where the hydrogen bonding could occur.